the result of the audit. And let me also show you the discussion. By the way, here you have an example of how you can structure the program. So in this example, there is a thread for the operations. And in this case, each thread will perform a number of operations, one after the other. And the parameters are to be randomly generated or read from a file or whatever. And the audit or whatever check function you have should run on one or more threads, where it runs several times in the middle of running those operations. And one way to achieve that is you have a loop. You say how many times you want to run this function on this particular thread. You run the audit function, and then you call sleep for again a small random value, so that you give time to the transactions to start and to do something, and then you will come back after a while to check that the consistency is verified. And now regarding passing the values, the thread function has the counts, and it calls audit with passing further this variable. And there are several ways of passing it in the creation of threads. The most explicit one, not necessarily the preferred one, is with creating here a lambda. So an unnamed function that captures the environment, the variables from the scope where it is defined. And this is the basic syntax that's compatible with C++ 11, where if you want to be explicit, for each variable that you want to use in your anonymous function that you are creating here, you specify here either like this, which means you create a copy of your variable, or with an amp sign in front of it, which means that you take it by reference. By the way, this should be const, and this should also be const. And then this should be mutable. So some C++ issues. And you can specify if a variable is allowed to be modified or not. And then you need to be const correct. And when you lock or unlock a mutex, those operations are not const, so they are incompatible with telling that the count is const. But the keyword mutable means the variable that is here can be modified whether or not you are in a const context. So it's quite often that you will see something like this with the data structure, with the mutex, and the mutex is marked mutable. And now you can also pass it by value without the compiler complaining about that. But if you put something like this, then the functional object here will get a copy of the vector here. If you put an amp sign, then it receives only a reference to it, which is more efficient. So this is the most explicit way of passing the parameters. Actually, what happens behind the scenes is that you get an object, the functional object, that has one member variable for each of the captured variables here. If it's captured by value, then it's a variable of the original type, so a vector. If it is captured by reference, then it's a pointer that will point to the original variable. And then there is a function that has this function body. And the functional object is passed to the thread constructor, and the thread constructor knows what to do with that. Actually, you have a lambda, and at some place inside the thread constructor, which is a template, the thread constructor creates an std function object that is with the polymorphism that's needed in order to accommodate this data. Anyway, always be careful with the arguments that are passed to a thread function, so that they exist for the whole life of the thread function. So for instance, here the accounts is passed by reference, and it's a local variable in main. Now, this variable exists until the end of life of this function, because we create here the thread and we join the thread here. So main will not end before the thread functions that are using the accounts end as well. But if you start the thread from some other function, then you have to be careful. In languages like with managed memory like Java and C#, you have the garbage collector that will notice that the variable is in use and will not reclaim it. However, there is trap in C#. Let me new project.
C#. Very keen.
Set as startup project. I don't need this. Okay, it runs. Good. Now, let's say we have a thread function which takes a number as input, and it simply prints the number. Presumably it does something with that number. And now from main, okay. Okay, good. I guess they covered a bit the thing here. Okay, equals new list of thread. I guess it's within. And I have to join it. Okay, let's see. Thread has not been started. Okay, so let me do it another way. How nice that C++ starts the thread immediately. So I create a thread, I add the thread, and I also start the thread. No. It's even better if I start them here. Now, I don't know if you can see exactly what's happening here. I would have expected to have numbers from 1 to 10, actually from 0 to 9, and all the values that are printed are 10. Do you know what's the issue here?
I think it passes I by reference.
Yes.
And it doesn't get to print. I mean, it prints them after they're all started, so it starts printing after I already became 10.
Yes. And the way around is to say simply int j equals I, and here pass j instead of I. And now I guess I get all the values from 0 to 9. And of course, since this happens in a multi-threading environment, it's unpredictable in which order the thread run, so I get a random permutation of the numbers. So 7, 2, 4, 1, 5, 3, 0, 8, 6, and 9. So I get all the values, but shuffled. Now, this is a classical trap in C#, a classical problem. In Java, for instance, at least originally, they covered for it because they wouldn't allow to pass. They also didn't have proper lambdas, but you had to create a class that was derived probably from Runnable. And you could create the class locally and capture from the surrounding variables, but the captured variables had to be final. Now, C# doesn't have anything like final or const with respect to local variables. You cannot say something like that unless they added something recently. There is a read-only, but it's not allowed here. It's allowed only at the class level. So I could say something like this, but I cannot do the and set it in the constructor, but I cannot do it at any other level. Okay, so be careful about the lifetime and copy versus reference, or pass by value versus pass by reference, especially when dealing with the thread function. And now back to this place. Back to the accounts. How to get the value back? Now, if you look at pthread join, you can get here as the second argument. You pass a pointer to a pointer variable, and you can get here whatever the thread function returned. The thread function must return a generic pointer, so a void star pointer to void, and you can get it from the join function. Unfortunately, you don't have the same thing in C++. So join is declared like this. There's no place to get some value from the thread function. So if I write the audit thread function to return, let's say, a bool, I cannot have access to that bool. However, I can pass in a reference to a variable and have the thread function modify that variable. And in this case, I'm interested only in knowing if an audit fails. So I put an atomic Boolean variable initialized with true. And if an audit fails, I store a value of false. And this is enough for this particular case. More complex scenarios would, of course, require more complex solutions. Questions or comments? Then I suggest to do the following. I close the meeting here, and if you have any questions or if you finish your lab and you want to present it, I will be available till the end of the class. So thank you and see you next time.
See ya.
Bye.
Thank you, goodbye.
Goodbye.
Mai ești aici? Alo, vezi că a închis proful labul.
Okay, yeah.
Vezi că s-a terminat labul.